Dear student, thanks you all for watching my lecture. Today I will discuss about HSC Physics for English version, first paper, chapter 2. The name of the chapter is called Vector. The name of the chapter 2 is Vector. Okay. At first we have to learn quantities. Now my question to you, what is quantities? The quantities is nothing but anything that can measure is called quantities. In our physics, quantities mainly two types. One is fundamental quantities, another is derived quantities. Okay, my dear student, now my question to you, which quantities will be fundamental and which quantities will be derived? Okay. The fundamental quantities of those quantities that cannot depend any others quantities is called fundamental quantities. For fully expression of these quantities, this quantity cannot need to help any others kind of the quantities. Okay, my dear student, I think that all of you clearly understand. Okay, there are 7 types of the fundamental quantities. How many types? 7 types of the fundamental quantities. Number 1, time, temperature, 3, length, 4, mass, electric current, 6, luminous intensity, 7, amount of substance. My dear student, these are the 7 types of the special quantities. These special quantities do not depend upon any other kind of the quantities. So this quantity is called fundamental quantities. Okay. Now we discuss about derived quantities. Which quantities will be derived? Suppose force is a derived quantity, because force, if we divide force, then we get mass and acceleration. Force divide two quantities, one is mass, another is acceleration, another is work. Work also a derived quantities. My question to you, why work is a derived quantities? Because work depend force and displacement. Okay, as work depend two quantities, force and displacement, and force also depend mass and acceleration also depend velocity and time, and velocity also depend displacement and time. Because of that reason, work, force, these are the derived quantities. I think that all of you clearly understand. If you face any kind of the difficulties, then write down to your comment on the comment section. Okay, these are the mainly 2 types of the quantities, but according to the expression, according to the expression, quantities will be 2 types according to the expression. My dear student, I think that all of you clearly understand. According to the expression, quantities also will be 2 types. One is scalar quantities, another is vector quantities. My dear student, according to expression, quantities will be 2 types. One is scalar and another is vector. Now my question to you, which quantities will be scalar and which quantities will be vector? Okay, the quantities that for describing or for expressing only we need magnitude. There is no need direction. The name of those quantities is called scalar quantities. So my information to you, actually for describing or expressing quantities, only we need magnitude. With the help of magnitude, we can able to describe scalar quantity fully and perfectly. But in case of the vector quantities, the quantities that for expressing of those quantities, we need 2 things, or we must have to confirm 2 things. One is it magnitude plus direction. direction. My dear student, I think that all of you clearly understand. In case of the vector quantities, for expressing fully and perfectly, we must have to confirm two things. One is its magnitude and another is its direction. This is very important. This is very important. For expressing vector quantities fully and perfectly, we must have to confirm how many things? Two things. One is its magnitude and another is its direction. Without two things, we cannot able to express vector quantities fully and perfectly. Now, my question to you, in case of the scalar quantities, magnitude is enough to expression fully and perfectly. Now, I give you some example of scalar quantities and vector quantities. Number one, suppose number one, time is a scalar quantities. Number two, distance is a scalar quantities. Number three, temperature is a scalar quantities. 4, work is scalar quantities. 5, potential is a scalar quantities. My dear student, in our physics there are three types of the potential. One is electric potential, another is magnetic potential, electric, magnetic, and third one is gravitational potential. My dear students, these are the example of scalar quantities. Number one is time, number two distance, number three temperature, number four work, number five potential. Potential mainly nothing but it is one kind of the special work. There are three types of the potential. One is electric potential, magnetic potential, gravitational potential. Number 6, moment of inertia. This is very new term for you, new topics for you. Moment of inertia. Moment of inertia is a scalar quantity. My question to you, what is moment of inertia? In the next part I am trying to discuss you. Okay, number 7, density is a scalar quantities. Okay, now we will discuss about some vector quantities. These are the special example of the scalar quantities. Now my question to you, why time is a scalar quantities? Because we can express time only with the help of its magnitude. Suppose now the time is 9 p.m. or 9 a.m. 9 p.m. or 9 a.m. is the magnitude of the time, so there is no need any other information for expressing time perfectly. My dear student, distance also is scalar quantity. Why distance is a scalar quantity? Suppose the distance between Rangpur to Dhaka is 2.5 km, 250 kilometer. 250 is the magnitude of the distance, so we can able to describe or describe perfectly and clearly with its magnitude. As the same way, temperature also is scalar quantity. Why temperature will be scalar quantity? Because we can express fully and perfectly with the help of its magnitude. Suppose the today's temperature is 25 degrees Celsius. 25 degrees Celsius is the magnitude of the temperature. Because of that reason, temperature is a scalar quantity. Now work, as the same way, work also is a scalar quantity. Now my question to you, why work is a scalar quantity? Because if a person or any kind of the electric engine perform 20 joule work, 20 joule work is the magnitude, so we clearly understand. Suppose there are two men, one man perform 100 joule work, another man perform 200 joule work, so we can clearly understand which person worked done more. Okay, my dear student, because of that reason, with the help of the magnitude, work can describe fully and perfectly. As same as potential, there are three types of the potential. One is electric potential, magnetic potential, gravitational potential. So this is also represent work. Moment of inertia. What is moment of inertia? Moment of inertia is nothing but it is one kind of the product of mass and square perpendicular distance between the rotational axis and the mass. I am trying to discuss what is actually called moment of inertia. Last one, density, and these are the special example of the scalar quantities. Okay, my duty is to clear you what is potential and what is moment of inertia. Okay, now we discuss what is moment of inertia and what is potential. Okay, my dear student, as already we learned this part, so we erase from our whiteboard. Okay, now we try to discuss about moment at first we discuss potential, electric potential. At first we discuss electric potential. Why electric potential is a scalar quantity? Now I am clear to you. Suppose here has a charge, this is the positive nature. Okay, here has a charge, q amount of charge is placed here, so the nature of the charge is positive. Around this charge here has a electric field. Around this charge here has a electric field. If we put any kind of the charge within this boundary, then this charge attract or repulse. Okay, now my question to you, how we can clearly understand the nature of this charge and in which region this charge create electric field. For testing this region of electric field, we must have to need a charge. The nature of that charge we know. The name of this charge is called test charge. Suppose the test charge is Q naught. Q naught is test charge. Okay, as the nature of the test charge already we know, the nature of the test charge all the time will be positive nature. Okay, the charge that already created electric field, if we place here my test charge, if we get there is no attraction or repulsion, that means here there is no electric field. Okay, when we just put here there is no attraction and repulsion, so we clearly understand there is no electric field. Again we input here this charge, test charge Q naught, then we cannot get attraction or repulsion, so we clearly understand there is no electric field. But when we input here Q naught amount of charge, Q naught amount, after input Q naught amount of charge inside within the boundary, if we get repulsion force, then we clearly understand the charge that already create electric field is a positive nature. My dear student, this is very important. Okay, if we face repulsive force or repulsion force, then we clearly understand the nature of this charge that already created electric field is called positive nature. Okay, why the charge is positive nature? Because we get repulsion force. Okay, if we get attraction force, then we clearly understand with the help of our test charge, the charge that already is created electric field is negative nature. Okay, suppose after placing Q naught amount of charge inside the electric field, we get a repulsion force. Suppose this is the direction of the repulsion. How much amount of the repulsion force we actually experience here? F amount of repulsion force. Okay, if we have taken Q naught amount of charge from outside to any point of the electric field, suppose if we have taken Q naught amount of charge from infinity region to any point on an electric field, then we must have to apply force opposite direction. As the nature of Q naught amount of force is positive and the charge that already created electric field also positive nature, so when we comes here, this charge apply force Q naught amount on Q naught amount of charge this direction. If we have taken this charge from infinity, this is infinity region, this is infinity region. Okay, infinity region. If we have taken q naught amount of charge from infinity region to any point inside the electric field, then we must have to perform some work, because we must apply force and here occur displacement. Suppose for taking q naught plus q naught amount of charge from infinity region to any point inside the electric field, the amount of work done is W. In case of taking 1 coulomb charge, the amount of work done will be W divided q naught. So W divided q naught work done is called electric potential on that particular point where we have taken the charge from infinity region. My dear student, I think that all of you clearly understand. So potential is nothing but it is one kind of the work. In case of electric potential, it is for work for taking 1 coulomb charge from infinity region to any point inside the electric field. The amount of work done is called electric potential. As magnetic potential is same, gravitational potential is same. In case of the gravitational potential, for taking 1 kg mass of the object from infinity region to any point inside a gravitational field, the amount of work is called a gravitational potential. My dear student, I think that all of you clearly understand why potential is a scalar quantity. My question to you, what is potential? Potential is nothing but it is one kind of the work. As in our previous section we learned work is a scalar quantity, so electric potential also a scalar quantity. Now I will discuss about moment of inertia. Moment of inertia is also a scalar quantity. What is moment of inertia? Now I am trying to clear you. My dear student, if you face any kind of the difficulties to understand my lecture, then please write down your comment on the comment section. I am trying to repeat this part again. Okay. Suppose moment of inertia. What is moment of inertia? Moment of inertia. My dear student, today as this is very new topics for you, totally new topics for you. What is actually moment of inertia? Suppose this is the marker, this is another marker. As this marker has mass, if this marker rotate around this marker, then we call this marker is a rotational axis. Suppose when this marker rotate around this marker, then in this situation it is called moment of inertia. Okay, suppose here has a mass, m amount of mass, and this is a rotational axis. X prime is a rotational axis. When any kind of the mass rotate, in this situation we get moment of inertia. Suppose the perpendicular distance between the mass and the rotational axis is r. M is a mass that already rotate around this axis, and r is a perpendicular distance between the mass and rotational axis. Suppose this is the rotational path. Okay, around this path m amount of mass rotate. Okay, the definition of moment of inertia is product of mass and square perpendicular distance is called moment of inertia. What is moment of inertia? Product of mass, m is a mass, r square, r is a perpendicular distance between rotational axis and mass. So we start our definition. Product of mass and a square perpendicular distance between the rotational axis and mass is called moment of inertia. My dear student, as mass is a scalar quantities and distance is a scalar quantities, so the product will be scalar quantities. Okay, if we product to scalar quantities, then result will be scalar. If we summation to scalar quantity, then we get the result scalar. If we divide or if we subtract to scalar quantities, then the result will be scalar quantities. My dear student, I think that all of you clearly understand why moment of inertia is a scalar quantities. Now again we try to repeat. What is moment of inertia? Moment of inertia is nothing but it is one kind of the product of mass and square perpendicular distance between the mass and rotational axis is called moment of inertia. When we get this term, when any kind of the object rotate, in case of the rotating any kind of the object, then in this situation we get moment of inertia from this object. Okay, I think that all of you clearly understand. My dear student, already we complete scalar quantities. Now we describe some vector quantities. Today I just list out which quantities will be vector. Suppose example 1, displacement is a vector quantity. Number 2, velocity is a vector quantity. Number 3, acceleration and deceleration. Acceleration and deceleration is a vector quantity. Number 4, force is a scalar quantity. Number 5, torque. This is also new topics for you. Torque, TORQE. My dear student, I think that all of you clearly understand displacement, velocity, acceleration and deceleration, force, torque. Number 6, surface momentum. In our physics there are two types of the momentum. One is linear, another is angular. Okay, in this situation displacement also two types, velocity also two types. Okay, acceleration and deceleration also two types. One is linear and angular. My dear student, displacement in our physics chapter, displacement mainly two types. One is linear displacement, another is angular displacement. Both displacement will be vector quantities. Velocity also two types. One is linear velocity and another is angular velocity. At the same way, acceleration and deceleration also two types. Force also in our physics we learn different types of the force. Okay, in this section we learned actually linear force and angular force, and angular force is called torque. Torque is a rotational, torque is one kind of the rotational force. Okay, momentum also two types, one is linear and angular. Number 7, surface tension. Surface tension also vector quantities. Number 8, surface tension also vector quantities. Number 8, pressure. Number 9, area can be used scalar and vector. So here we learn area is a vector quantities, pressure also vector quantities. Okay, sorry, pressure is a scalar quantities. Okay, pressure will be scalar quantities. Okay, area, surface tension. Okay, these are the good example of vector quantities. My dear students, now I am trying to discuss why displacement is a vector quantities, why velocity, why force, why torque and momentum and surface tension is a vector quantities. Now we try to discuss. Now my dear student, displacement. What is displacement? At first we discuss about displacement. What is displacement? Displacement is nothing but, suppose if a person or object straight journey from here and want to go from point B. The person or object has a lot of option. This person can able to move from A to B following this direction, and this person also go from A to B this direction and also this direction, and third one is this. Okay, here has a many option of this person or body to go from A to B. If this person follow this path, and this path will be the number path 1 will be the shortest distance between A to B, and this shortest distance is called displacement. But number 2 option, number 3 option and number 4 option is not a shortest distance. Because of that reason, this number 2, 3 and 4 option cannot be represent displacement. Only one option is shortest here, that is number 1. Number 1 is represent displacement. So any kind of the distance cannot be displacement. Only shortest distance is called displacement. Okay, all the displacement is distance, but all the distance cannot be displacement. My dear student, I think that all of you clearly understand. Okay, here also has another scalar quantity number 9, speed. My dear student, speed and velocity is very important part here. Suppose if we write another diagram, already we clear displacement. Now we try to discuss about distance. Already we learned displace and displacements, although now we try to discuss another diagram. Suppose a person starts journey from here and go to point B and not stop here and comes from C. Okay, as this is the initial point and this is the final point. Okay, my dear student, we know that the shortest distance between initial to final is called displacement. The shortest distance between initial to final will be this red line represent the initial minimum or shortest distance between initial point to final point. So it has a direction. This direction represent A to B. Okay, this is the displacement. So displacement is a vector quantity. Okay, but if we take the A to B, B to C, A B plus B C is a distance. Okay, and AC represent the displacement. My dear student, if we have to measure the distance, how much time is needed to cover this distance, then it is called speed. Now we try to discuss about what is speed and what is velocity. Speed. Okay, my dear student, what is speed? Speed is nothing but, suppose here has distance A to B and B to C. Suppose A to B plus B to C. This distance, for covering this distance, the time is needed T. So it is called speed. The distance traveled by 1 unit time is called speed. So equation of speed will be total distance by total time. So this is the equation of the speed. So unit will be meter per second. And if we measure velocity, then we must have to measure how much amount of the displacement occur here. Suppose AC amount of displacement occur by time t. In case of 1 unit, suppose in case of t unit time, the displacement will cover AC. For 1 unit time, the displacement will be AC divided t. So AC is a displacement and time. Displacement divided time is called velocity. My dear student, I think that all of you clearly understand and can able to differentiate what is speed and what is velocity. The unit of both two quantities is same. This is also meter per second. the unit of velocity also meter per second and unit of speed also meter per second. My dear student, I'm trying to clear you why displacement is a vector quantity and distance is a scalar quantity, because there is no direction, it has direction. Initial to final is the direction of the displacement. My dear student, because of that reason displacement is a vector quantity, and for expressing displacement then we must have to need two things. One is its magnitude and another is its direction. Okay, now we try to discuss why velocity is a vector quantity. Why velocity is a vector quantity? Suppose here has a tree, suppose here has a tree, suppose this is a tree, okay, tree. A person is standing here, okay. If we asked a person, you start journey here with 10 meter per second velocity. Suppose if you call this person, you start running with 10 meter per second velocity. My dear student, 10 meter per second velocity is the magnitude of the velocity. Magnitude of velocity. The magnitude is 10 meter per second is the magnitude. Now my question to you, in which direction actually this person will be running, okay, this is my question, okay. This person will be confused if we do not clear the direction. If we called this person start running 10 meter per second velocity toward the east side, then this person clearly understand I have to move from east side toward the east side with 10 meter per second velocity. So 10 meter velocity is the magnitude and east is a direction, east side is a direction, okay. If this person move north side, this is west, north, south, and this is west. If we call this person start journey 10 meter per second velocity toward the north direction, then this will be clearly understand this person I have to move toward the north direction, okay. Because of that reason velocity is a vector quantity, because this person has a lot of option to start journey from here. This person also can start journey making angle with the east side 30 degree and 10 meter per second velocity. My dear student, because of that reason velocity is a vector quantity. Without two things, one is its magnitude and direction, you cannot able to express these quantities perfectly and clearly, okay. As like as force, suppose here has a box, suppose this is the box, suppose A, B, C, D is a plane, E, G, F, okay. If we called you apply 10 Newton force on the box, then you will be very confused in which surface we apply. We have a lot of option. We can apply 1 force upward to downward direction and left to right and right to left, okay, or down to upward direction. So we have a lot of option. So without clear its direction, then we cannot able to express force perfectly and clearly. My dear student, I think that all of you clearly understand why force is a scalar vector quantity and velocity is a vector quantity, displacement is a vector quantity. In our next lecture, I am trying to discuss others vector quantities fully and perfectly. If you like this video, then please like, share and comment on the comment section. Thanks to all for watching my lecture.